Welcome to Unit 2. We're going to talk about matter and its classification. You can see I already started writing on this before I started recording. Anyways, matter is important in chemistry. We talk a lot about its characteristics, and so we're going to learn about that in this lecture. So matter is anything that has mass and occupies space. Some of the terms that you might hear me use in this lecture that I thought would be helpful to define before we get into the lecture. Atoms. An atom is the smallest identifiable part of an element. Smallest identifiable part of an element. And molecules, sometimes you hear this term used as well. Molecules are elements that are held together by covalent bonds. So it's like they're elements held together by covalent bonds. And we haven't really talked about covalent bonds yet. We will talk about that later in Unit 2, but I just wanted to give you an idea of these different terms. An example of a molecule that you are very familiar with is water. So for example, water, H2O, is a molecule. So water is made up of 2 hydrogen atoms and 1 oxygen atom. And, that H2O is a molecule. If you find 1 molecule of H2O, that's water. If you found, 50 million molecules of H2O, that's also water. It's just a lot of water molecules. And the atoms, the hydrogen and the oxygen, are used to build that molecule. Now, part of this lecture that I'm doing, you're probably familiar with a lot of these terms. Solid, liquid, and gas. You've heard these before, and I'm just going to give you definitions that you probably know, but maybe you just don't think of them. You have been so familiar with solids, liquids, and gases all your life that you just kind of take it for granted. So a solid, you come across this, so many examples of solids that you encounter every day. Your writing utensil, you have probably a plastic pen, that's a solid. You come across wood, that's a solid. You come across ice, that's a solid. Metal, solid, all these different examples. The one thing about a solid is sometimes in chemistry you'll see it abbreviated with a parentheses S, and a solid maintains its shape and volume regardless of its location. So a solid maintains its shape and volume regardless of location. Okay? A liquid, probably, a water that you come across. When you drink water, it's in the liquid state. You might have ice in your water, that's in the solid state, so you have 2 states. So liquids are commonly abbreviated in chemistry, parentheses L. The thing about liquids, liquids occupy a definite volume but assume the shape of the container. Occupy a definite volume but assume the shape of their container. You see this a lot with children. I've experienced this with my own children. They're fascinated with water. Water can be the best toy. And one thing, that our children still never tire of is, in their preschool age, they love to pour water back and forth, and just that kind of exploration of what's going to happen if I pour this water from this pitcher onto the table. Parents are like, don't do that. But to a child, they're just exploring the properties of these liquids. And of course, then it runs over the table and onto the floor, and it might run into other things, and it might get into other trouble. But that is unique to liquids. A liquid has a definite volume, like you can buy a 2 liter of soda, but the shape is the container that they're in. So whatever the shape of the container, whether it's a 2 liter bottle, whether it's a pitcher, whether it's a tabletop, whatever it may be, it just assumes the shape of that container. Now, a gas. Gases we don't have as much experience with, but they're definitely present. We breathe in oxygen, which is in a gas state, very important, and we breathe out CO2. So, but it's a gas. It's kind of one of those mysterious things. It's there, but it's not. We can't see it, right? So a gas, the way it's abbreviated in chemistry is parentheses, lowercase g. So the unique thing about a gas is that it maintains neither the shape nor volume of anything. So it has no shape or volume. It assumes the shape or volume of the container it's in. So I've put together this little table at the bottom of your note packet. Just kind of a useful summary of what we've gone over. A solid, remember that would be like ice, a block of wood, plastic, any solid that you come into contact with. It has definite shape and definite volume. If you think about a block of wood, which is solid, if it's a cube in a cube shape, then to take the volume of that block of wood, you would just take the length times the width times the height, and you would get the volume. All right, now a liquid has definite volume. Think of a 2 liter of soda. But the shape is the shape of the container. So takes shape of container. Now a gas, we just talked about this, where the shape and volume are both of the container. So container. So it does not have definite shape or volume. Okay, so now we're going to go on to page 2 and talk more about matter. So we've talked about solids, liquids, and gases. Now we're going to talk about matter and how it can be further subdivided. So matter can be divided into 2 groups. We have pure substances, and then we have mixtures. So a substance has a definite or fixed composition that does not vary from one sample to another. All right, a mixture, on the other hand, is variable. So a mixture is variable. The substances retain their identities. They do not change chemically, they just mix. So retain identity, but mix. Okay. So pure substances can be further subdivided into elements and into compounds. An element is the simplest chemical you will come across. So it's one of the fundamental substances from which all materials are constructed. It cannot be broken down into any simpler substance. So cannot be broken down any further. An example of an element that we're all familiar with, gold. So gold. It's a pure substance and it can't be broken down any further. Now, a compound is made up of two or more elements that are chemically combined. Two or more elements chemically combined. Now remember, it's under the pure substance heading. So that means, you can have a compound that is a pure substance. Think about water. This is a compound made up of elements, H2O, so you have hydrogen and oxygen that have been combined in a particular ratio to make this compound. So these are pure substances of matter, so elements or compounds. Now on the other side of matter, we have mixtures. And so remember I mentioned that mixtures are variable, they retain their identity, but they mix. So there are two types of mixtures that you can come across. You have a homogeneous mixture, and that is they have the same composition throughout. So same composition throughout. A heterogeneous mixture has a different composition throughout. Maybe a better word to use instead of different is variable. So variable composition throughout. Sometimes students struggle with understanding the difference between homogeneous and heterogeneous. And so the best example that whenever I think about these types of mixtures, I think of peanut butter. So if you get creamy peanut butter, that would be an example of a homogeneous mixture. Creamy peanut butter. Now when I was growing up, I grew up in a family of chunky peanut butter lovers. My mom and dad loved chunky peanut butter. I liked creamy peanut butter. Nobody liked creamy peanut butter in my family. I was the odd man out. So when finally on my own, I'm going to get creamy peanut butter. It's so exciting. So, anyways, funny how you remember these things. And now it's a good example for chemistry. So the chunky peanut butter would be an example of a heterogeneous mixture. You can see the cream of the peanut butter, and you can also see the nut from which the cream originated. So the two components in that mixture are very discernible. And that's what you come across when you have a heterogeneous mixture. That's how matter can be subdivided. And we'll learn all these different things. We'll talk about elements more, compounds, mixtures. But just kind of some simple definitions, but kind of thinking about it, hearing it, getting a new way to look at it can be helpful in learning this. All right, I have a question for you. Classify each type of matter as a pure substance or mixture. If it is a pure substance, classify it as an element or compound. If it is a mixture, classify it as homogeneous or heterogeneous. Okay, the first example, mercury in a thermometer. Mercury is an element. The abbreviation is Hg. Oh, sorry, let me scoot this up for you. So mercury is an element. So in a thermometer, it's just going to be, this will be an example of an element. So that would be a pure substance, the most fundamental substance, an element. Okay, exhaled air. Sometimes students get confused about this. So like, is it a mixture? Is this? Exhaled air is usually CO2. So when I ask this question, I make it clear that it's CO2. So CO2 is matter. What type of matter is it? It's a pure substance. So you're going through this flowchart, matter, pure substance. It's not an element because CO2 is made up of carbon and oxygen. It's a compound. So I guess I didn't fully answer this first question either. Pure substance, element, pure substance, compound. Okay. The next example, C, chicken noodle soup. So if you think about chicken noodle soup, you have your chicken broth, and you have your noodles, and you have your chicken, and depending on your recipe, you might have some carrots, and you might have some celery, and you might have some onions, maybe some garlic. Everybody makes theirs differently, or maybe your brand makes them differently. But this is a mixture. So if you think about dipping your spoon into your mixture, your soup, when you look at the soup before you eat it, you can see the different components. You can see the carrot, you can see the celery, you can see the noodle, maybe you'll see the onion, you can see the broth. So this is a heterogeneous mixture. So this is a mixture, and it's heterogeneous. All right. The last example is sugar. And sugar, it doesn't say it's mixed in water. If it was mixed in water, then it would be a mixture, so it's just sugar. So it's a pure substance. Sugar is not an element, but it's made up of elements, so it's a compound. It would be helpful if I gave you the formula for sugar, C12H22O11. Double check that real quick. Yes, so that is indeed the correct formula for table sugar, which is sucrose, C12H22O11. I know the formula well because I love sugar, although I know it's not very good for you. Anyways, back to the question. The question asks whether it's a pure substance or a mixture. We've already determined that it's a pure substance. It's not an element, but it's a compound. So it's a pure substance, and it is a compound. Okay, so that concludes our first lecture in Unit 2 on matter. And I will just keep posting more lectures on Unit 2, so that hopefully it will be easier for you to understand. Until next time.